Okay, what's really going on inside a simple glass of water? Let's uncover some of its hidden forces.
Believe it or not, all these things are connected. The answer? Fluid mechanics. Let's dive right in.
All right, here's our game plan. We'll define fluids, look at them at rest, then in motion, and finally, check out gas laws.
So, first up, what is a fluid? Basically, anything that flows. That covers water and even the air.
First property is density. It's why oil floats on water. It's just less mass packed into the same space. Then there's viscosity, which is just a fluid's thickness. Think honey versus water. That's high versus low viscosity.
You know how water forms beads on a leaf? That's cohesion. The water molecules are all sticking together.
And adhesion is kind of the opposite. It's water sticking to other things, like a paper towel soaking up a spill. Now, a huge difference here is compressibility. You can squeeze air into a tire, but you can't really do that with water. So, the study of fluids splits into two big areas. First up, we've got hydrostatics.
That's all about fluids at rest. And believe me, even still, fluids have some incredible power.
This is all thanks to Pascal's law. Basically, pressure in a closed container goes everywhere equally. So how does that let you lift a whole car? Well, the answer is in something called a hydraulic system.
You see this everywhere, in jacks, lifts, even your car's brakes. They all use this principle to multiply force.
And here's the magic. A tiny input force gets turned into a huge output force. It's incredible.
Okay, that's fluids at rest. But what happens when they start moving? This is hydrodynamics.
Enter Bernoulli's principle. And it's simple. Faster fluid means lower pressure. It's literally how planes fly.
Flow isn't always simple, though. It can be smooth, or laminar, or it can get chaotic and turbulent.
Remember how we said gases are special? Since they're compressible, they follow their own set of rules.
These laws connect pressure, volume, and temperature. Boyle's law is why a balloon expands as it floats up.
So let's recap. We've seen how fluids work at rest and in motion, from hydraulics all the way to how planes fly.
These forces are everywhere, and understanding them is key. So the real question is, what will we build next?